continuing to talk about rational exponents. So for any real number a and a positive integer m and n, where n is greater than 1 because you can't have n is equal to 0, we can say that if we have b to the mn, that's the same thing as b to the m power. Notice that that's b, that the numerator is the power, and then the n is the root. So we're just taking that same concept of, you see here and back in this example, 16 was being taken to the first power. We just ignored that first power. This would be the same thing as the nth root. Because of the denominator, that becomes the nth root of b, and you could take this whole thing to the m power. Okay, so let's look at how some of these examples would work out then. So write each expression in radical form and then simplify it. If the result is a not real number, state that it's not real. So because the 2 is in the denominator, what is the root? Square root. So this is the square root of 25 to the third power. Now, I could also take 25 to the third power and then take the square root, but I think it's actually easier if you take the square root of 25 first, because 25 to the third power is a really big number. So does everybody see how I got the root and how I got the power? Based on the numerator is the power and the denominator is the root. So what's the square root of 25? And then we take 5 to the third power. Does anybody know what 5 to the third power is? 125. Okay. Here, I'm going to take the cube root of 64, and then I'm going to square it. So the cube root of 64 is a perfect cube. It's going to be 4, because 4 times 4 times 4 gives us 64. If you want to, write out all the factors, you can. And then 4 squared is 16. So here we're going to take the third root of negative 64, and then we're going to square that. So the cube root of negative 64, what do you think? Can we take the cube root of a negative? Yes, because remember, it's a number times itself 3 times. So that would be negative 4, and then square it. So anytime you have a negative, if you have an odd index, you're fine. And then what do we get here? It would actually be a negative times a negative gives us a positive 16. Okay, questions on that? Okay, I'm going to turn the page to the next side. And all of these laws of exponents, you can review them from chapter 5. So chapter 5 of Math 65, we talked about laws of exponents. So if I have, for example, x to the third power times x to the second power, what do I end up getting? X to the fifth power. So when you have the product rule, product means multiply. If you're multiplying the same base with 2 different exponents, the rule is that you add the exponents. If you said multiply them, you're getting it confused with the product rule. So the product rule, this is slightly different, right? X squared to the third power would be what? X to the 6th. And so what did we do with the exponents here when we take power to a power? We're going to multiply those exponents, right? So these are 2 different rules. And if you're struggling with the rules, I always suggest making flashcards. And I have some flashcards. I can get them out later to review this. What about the quotient rule? If the product rule was to add, what's the quotient rule? Subtract. So a to the m minus n. And an example of that, if you have x to the third power and you divide it by x squared, what would you get if you were to divide those? Yeah, x or x to the first is the same thing, right? Now, if we have the power and the product rule at the same time, basically both things are in exponents, are in parentheses, we would have a to the n times b to the n. And that's important because, for example, if you had 3x and you were squaring that whole thing, that would basically mean you're going to square the 3 and you're going to square the x because they're both inside the parentheses. So what would you get there? Excellent. Okay. What about the quotient and the power? If I take 1/2 to the third power, that means I have to do it to both the numerator and denominator, right? So we would have a to the nth over b to the nth. Okay. And then what about the negative exponent? So let's say I have 1 over, oopsie, let's say I have x to the negative 1. What does x to the negative 1 do? It actually takes the reciprocal. So if you have a negative exponent, it flips it, 1 over a to the n. And that's because, and I have a whole set of videos on the negative exponent, but just really quickly, if I say x squared divided by x to the third, what would happen there if I subtracted? 2 minus 3 gives us negative 1. But notice I have 2 in the numerator, I have 3 in the denominator. If I canceled these, I would have 1 over x. So that's just the idea of making sure that with the negative exponent, we take the reciprocal. You can actually see that also on the calculator. Can you see it on the calculator? It's kind of washed out. Okay, right above your x squared key, you have an x to the negative 1. If you take 2 to the negative 1 power, you get 0.5. Why? The negative exponent has nothing to do with the sign of the number, right? So what did the negative exponent do to 2? If I take 2, I'll just write this down, 2 to the negative 1 power, I got 0.5, which is the same thing as 1/2. Because that negative exponent, what did it do to the number? Took the reciprocal. Okay, so the reciprocal rule, the negative exponent means to take the reciprocal. So before we were looking at using the square root because here's the index is 2 when we have 1/2. So here this would be the same thing as the square root of 25 to the negative 1 power. What's the square root of 25? 5. Where from that am I getting the square root from? What about that expression says I want the square root? Yes, the half. Okay, so that's 5 to the negative 1 power. What does the negative 1 power do? 1 over 5. And I would normally line it up vertically, but I ran out of room, so I'm writing it off to the side. Okay, what about this one? How is this one different? And where does that negative belong? Outside. So this is going to be the exact same problem equals negative square root of 25 to the negative 1 power. So how is that going to change our answer then? Negative 1/5. Good. Yeah? And then what about this one? This negative is inside. So here we would have the square root of negative 25 to the negative 1 power. So what's the square root of negative 25? Not real. Can't really take the reciprocal of not real. So if it's not real, we'll say it's not real. Okay, what about this one? What are you going to do with that fraction exponent? Yes, so right here, it's going to be the cube root of 8 to the negative 1 power. What's the cube root of 8? 2. What's the negative 1 power? 1/2. Very good. Okay, what about this one? The only difference is that negative out front, right? So essentially, everything is the same. Negative, still cube root of 8, still negative 1 power. Cube root of 8 is 2. 2 to the negative 1 power is 1/2. Yeah? Okay, what about this one? We want the cube root of -8, and we can take this whole thing to the negative 1 power. What's the cube root? Can you take the cube root of -8? Can you have a negative inside a cube? Why is it? Why can you have a negative? Ah, odd index. So here we have -2 to the negative 1 power. And what would that be? 1/2. Is it negative? It still would be negative because you're thinking about it, you're taking it really to the negative 1 power. It's not a negative times a negative. This negative means I want the reciprocal, but I still have a negative because you think about it, -2 to the first power is still -2. So they don't eliminate each other, okay? And now we can have a few challenge problems here, and this is where it gets a lot trickier, because you're going to put this together with the laws of exponents. So if we go back to the law of exponents when we're multiplying, what do we do with the exponents? Add them. So if I have the same base, m to the 1/3 plus 1/6. What do we have to do in order to add exponents? Or add fractions is what I meant. Yes, we need a common denominator. What's the lowest common denominator? 6. And so what do I need to do to this fraction here? 2/2, right? So we have m to the 2/6 plus 1/6 is what? M to the 3/6. Could you reduce that fraction? M to the 1/2. Now can we put it in radical form? The square root of m, right? It's the same thing as the square root of m. Okay, here, when we're dividing, what was our rule for our exponents when we divide? Subtract the exponent. So here we're going to have b to the 7/2 minus 1/2. Lucky us, they already have a common denominator. That's b to the 6/2. Good. Can you reduce 6/2? B to the 3rd. Yes, b to the 3rd. You see that whole process using all of those different laws of exponents. Now, what could we do here? We have x to the 3/2 times x to the 1/3 all to the 6. This is power to a power, right? So what do we do with the exponents? X to the 3/2 times 6 times x to the 1/3 times 6. What are some fancy ways to multiply these fractions here? Remember cross cancel? Because when we're taking power to a power, we can multiply. Here we get 2 goes into 6 3 times. X to the 3 times 3 is 9. Okay, 3 goes into 6 how many times? 2, that's cross cancel. X squared. And what do you get in the end? X to the 11th power. Okay, any questions on that?